Alright everyone, so today we're going to be talking about polynomial functions. This is 4.1. This is the first section of Unit 4. So you can read through this. A polynomial function is a function that is represented by a polynomial equation and is continuous, and it can be described by a polynomial equation in one variable. Very important, it's always in one variable. If there's multiple variables, it is not a polynomial function. If any of these things are true, if there's a radical, if there's variables in the denominator, negative exponents, finite number of terms, if any of these things are true or untrue, basically if there's an infinite number of numbers, negative exponents, this makes it not a polynomial, okay? The leading coefficient is the coefficient of the term with the highest degree. So it's really important that when we're dealing with polynomial functions that we make sure that we're in standard form, that the highest degree term is written first so we can identify the leading coefficient. And end behavior is what happens to the graph as we go to negative and positive infinity on the x. We determine what the function is doing as that happens. So classifying polynomials, there's two different types of classifications. We have the degree classification and then the number of term classifications, two different things. So 0 degree term, that would just be like a regular number where there's no visible x. That's going to be a 0 degree, okay? A single x with an implied exponent of 1 would be linear. Quadratic is second power. Cubic is the highest power term being 3. Quartic is 4, and quintic is 5. Now, number of terms gives us these other names, monomial, binomial, etc. So, if you have one term, that's a monomial. Two terms is a binomial. Once again, this is one term, it's a monomial. Even though it's quadratic, it's still one term. Cubic, in this case because it's the third degree, but it's a trinomial because there are 3 separate terms. This is a binomial because there are 2 terms. And then anything above 3 terms, we just call it polynomial of x amount of terms or n amount of terms. So there's 4 terms. We don't have any words for when it's more than 3. We can just call it a polynomial, and we can say how many terms there are. The same with quintic. Past 5th degree, we just say 6th degree polynomial, 7th degree polynomial, and so on. So poly means many, so a polynomial is many terms. The degree is equal to the highest exponent, also known as the, basically you can count the number of turning points and add 1 to that, and that will also tell you the degree of the polynomial if you're only given a graph. And then the leading coefficient is the coefficient of the leading term. In this case, the leading coefficient would be 4, this one would be 2, and this one would be negative 1. So all polynomials are either even, odd, or neither for symmetry. So even symmetry is if you were to literally reflect it over the y-axis, it would map onto itself. Odd symmetry is if you were to cut it in half down the middle of the y-axis. If you were to take one side, flip it upside down, and then flip it onto the other side, it would line up, okay? This is symmetry about the origin, okay? So basically just think, if I were to cut this side out, the left side, flip it upside down, and then map it onto the other side, like literally flip the paper onto the other side, would the two sides line up? Neither is when you have no type of symmetry over that axis or about the origin or anything like that. As you can see, these two don't have any type of symmetry over the origin or the y-axis. So there's a few different ways we can actually determine if something is even or odd based on the equation itself. So here's the shortcut. This right here is an even term, right? Because it's an even degree of 6. This is also an even term because it has an exponent of 2. Both terms are even, the whole function is even. Now there is an algebraic way to check this as well. If you were to plug in negative x, or technically this is negative 1x as a coefficient, into the function, if every single term stays exactly the same when you do that, that means it's an even function. So you replace all the x's with negative 1x. Of course, any negative number to an even power just becomes the positive version of that number. So it's just going to become 6x squared, or 6, oh my gosh, I can't talk, sorry. X to the 6 plus this is going to become even as well, and it's going to become 2x squared. So notice when I plugged in -1, nothing changed. Every single term stayed exactly the same. That makes it even. So for odd, you can do the same thing. If you plug in a negative x into the whole function, and the whole entire function becomes negative, as in every single term changes to become negative, that makes it an odd function. Now you can also do the same thing where you check each term. This term is to the 5th degree, so this is odd because 5 is an odd number. 3 is also an odd number, and then this is 1, right, because it's an implied 1. 1 is also an odd number, so this is an odd function. Now, once again, you can do the actual algebraic check by plugging in -1, like this. So as you can see, these are all going to become negative terms, because when you put any negative number to an odd power, it's going to stay negative. So you switch the sign on this one, the sign on this one, and the sign on this one changes, making it odd. Or you can do this quicker version of the check. And then neither is when you have a combination of the two, right? So in this case, I have an odd term. Remember, you look at the exponent, not the coefficient, okay? So that's why it's odd. 3 is an odd number. 2 is an even number. This is a 1, so that's an odd. And constants are always even, okay? And the reason for that, if you're wondering, well, why is that true? Well, let me explain. Technically, a constant in a function is the same thing as, say the constant is 1. I'll stick with this. It's actually 1 times x to the 0 power, because anything to the 0 power is just 1. Okay, so it's actually just an x to the 0 power there. 0 is an even number, so constants are always even. That's the reason why. So we have a mixture of odd and even. This makes it neither. All right, let's go ahead and classify some of these. First thing you want to do is you want to rewrite it in standard form. That means that the highest exponent has to come first, then the second highest, and the constant always comes last. The degree of this polynomial is determined by the highest exponent term, which is 2. The leading coefficient is the coefficient of that term, and the number of terms, 1, 2, 3. So terms are always separated by addition and subtraction, so that's how you can determine if something is a separate term. This particular one, we want to see if it's odd or even, or neither, of course. This term right here is odd, because it's a 1. This term here is even, and then, like I said, constants are always even. So this is a mixture of odd and even, so it's neither. This one here is can trip people up, because we have the 12x to the 4th as our first term, because that is the highest exponent. Now these are actually like terms, right? So we can actually go ahead and combine those. So what may look like a 4-term polynomial is actually a 3-term or a trinomial. So you have to make sure that you condense and simplify everything and then rewrite it into standard form before you determine how many terms there are. Very, very important. So the degree of this is 4, the leading coefficient is 12, and the number of terms is actually 3. So I have an even term, odd term, even term, so this is neither. This one here, you can see it's actually already in standard form for us, and there are no like terms for us to combine. So I can just rewrite it as is on the line. This is 4th, sorry, I don't know why I said 4th. This is 6th degree because the highest exponent term is 6. There is a leading coefficient of 5, and the number of terms is 4. A mixture of even and odd terms, so it's neither as a collective, right? This one here I'm going to rewrite in standard form. So one mistake I do see people make when they rewrite things in standard form is to make sure you take whatever the sign of that term is with it. This is an even, I'm sorry, mixing my words up. This is a positive term, right? So it's going to stay positive. This is a negative term, so it's going to stay negative when I rearrange it. Just because there's no plus sign in the front doesn't mean I can't put one there when I rearrange it to be the second written term. The degree of this is 4. The leading coefficient is -3. And there are 4 terms because there's nothing here I can simplify. There are no like terms. I have an even, odd mix, so it's neither. So these are the parent functions for the first 6 types of polynomial functions. We have degree 0, degree 1, degree 2, degree 3, degree 4, and degree 5. So the general shapes of the graphs of several polynomial functions show that the maximum number of times the graph of each function may intersect the x-axis. This is the same number of times as the degree of the polynomial. So let's talk about what end behavior is. So end behavior is what the function is doing as we go to the left and the right on the x value. So as the function gets to smaller and smaller x values and then larger and larger x values. So in this case, on this particular function, as you can see, it has 3 turning points. That's where we change from positive direction or increasing to decreasing, and then decreasing to increasing. So that's always going to be a turning point. So you can see there are 3 turning points, which makes this a 4th degree polynomial. There's always one more. Whatever the number of turning points are, you add 1 to that. That gives you the degree. So as you can see, the end behavior, as this function goes to getting to smaller x values, the function is going up. That's where this comes from right here. It's going to positive infinity. As the function gets to more large x values, the function goes up as well. Now you're going to notice that all the odd degree ones, see how the 2 ends always go in opposite directions? It could be flipped. It could be the other way around. One goes up and goes down, but see, they will always go in opposite directions, where the even degree will always go in the same direction. Alright, so now we're going to do some sketches. The domain of any polynomial function is all real numbers. The end behavior is the end behavior of the graph as we approach positive and negative infinity on the x. So even positive. So it's an even degree and the leading coefficient is positive. This is what the end behavior is going to look like. This would be something like your typical quadratic. It's always going to end upward. So there's multiple sketches that could do this, but even positive, your leading coefficient is positive, your degree is even, are always going to end upwards. So positive infinity, positive infinity. Even negative will always end downward on both sides. So minus. Something I always remind students is even will always go the same direction on both sides. So either up on both sides or down on both sides. Odd, positive. That's going to start down and end upward. So there's multiple different versions of this that you could look at. Any of these particular polynomials, you can go ahead and graph these in Desmos if you want to get a better look at what they look like. So as we go to the negative direction for x, the function goes down, and as we go to the positive direction, we go up. And then odd negative is the opposite. Starts up, ends downward. That's odd negative. So let me give you a few tips to help you remember. Even, anything even, always ends in the same direction. Odd always ends in opposite directions. Anything where the leading coefficient is positive always ends upward. So that's the way I remember all the different rules.